Okay, exponential growth. Exponential growth differs from other types in that it is a consistent percent of change, either increasing or decreasing. That percent of change is found by dividing a y value by its preceding y value. And in function notation, it will look like f of x equals a times b to the x. So our variable is in that exponential or in that exponent position. So let's look at a couple tables and see how we might identify this. In the first table, I have my x's going from 0 to 4 and my y's. Well, there's a consistent amount of change in this first table. It's plus 2, plus 2, plus 2, plus 2. In the second table, again, I have my x's going from 0 to 4, but there's no consistent amount of change. So it's b plus 1, and then plus 2, and then plus 4, and then plus 8. So there's not the same amount of change. So the next thing to check would be, is there a consistent percent of change? The percent, again, is calculated by taking a y value divided by its previous one. So 16 divided by 8 would be 2. So that suggests to me that my common ratio would be 2. 1 times 2 is 2. Great. 2 times 2 is 4. Okay. 4 times 2 would give me the 8, and 8 times 2 would give me the 16. So in this case, I do have a common ratio or a common percent of change. If we were to go ahead and plot the points, the values from the first table are this red line, and the values from the second table are shown in the blue graph, which definitely is not linear. That's what an exponential graph would look like.